Hello, friends. Hello,
Hello.
hello, hello. Check 1, 2. Nice to be here. I'm Kelly. Thanks for tuning in. If you're tuning in live, if you're not, welcome to the past. But today we'll be talking with the Kubefirst team. We have Jared underneath me. We have John underneath him. I'm Kelly, and I run developer relations for KubeShop. KubeShop is an accelerator focused on building tools for developers, SREs, QA testers, all of the above, specifically in the Kubernetes and cloud native ecosystem space. And you probably have heard of Kubefirst before. If you haven't, welcome. Get ready. These guys are building something really great. It is a fully automated open source application delivery and infrastructure management platform that focuses specifically on, well, not focus specifically, but gets into the GitOps system, I guess is the best way to say it. And we'll be talking a little bit about Argo CD in particular and GitOps, which go hand in hand. So Jared and John will be talking about best practices, some patterns, giving a quick demo on some of these as well. I think that's it what we have for today. So if you're tuning in live or if you're not, as always, feel free to put any comments and questions wherever you're watching. We'll check it out. We'll either address it as we go along or afterwards. I think that's about it.
That sounds awesome. Thanks, Kelly. We always like to start these live streams with just a quick overview. We're going to go quicker than we usually do on what Kubefirst is. But we struggle to describe Kubefirst without setting the table with Kubernetes itself. Kubernetes is obviously a best-in-class container orchestration engine. It's become the de facto standard for running containers in the modern day. And it does a really good job. We love it. We've been using it for, it's probably close to a decade at this point. Not quite, but we've been using it for quite some time. It has solved every single problem that we've ever thrown at Kubernetes. Kubernetes has been able to answer the problem in a technically sound way that everybody understands. It's done that for us. It's done that for everybody. The cloud native landscape is filled with vendors across the spectrum of cloud computing who have invested the last 5, 6, 7 years in making sure that their application runs really well in Kubernetes, because it's such a game-changing way to run software. You can run very, very complex software packages that used to require you to have all kinds of different virtual machines and load balancers and secrets management and configuration management, blah, blah, blah. You can have all of that immediately just by running a Helm install of a particular software package, and it'll deploy all of the microservices exactly the way that they intended for those services to run in Kubernetes. And as an operator, you don't need to dive deep into those details until it's time to start hardening these applications and getting into the various configurations of them. So because there's all these different cloud native tools that run really well on Kubernetes, companies are struggling adopting Kubernetes. They install Kubernetes, they go to their cloud provider, AWS, GKE, DigitalOcean, whatever. They install a Kubernetes cluster and it's empty, and that's not very valuable to anybody. And you have to sort of go through this process of learning all of these different tools that are on the cloud native landscape, figuring out which ones work well with each other, figuring out how to configure them with each other. And company after company is spending, months, sometimes years, learning these tools and figuring out what the right combination of patterns is to get a application delivery and infrastructure management ecosystem that can run your company and scale to the nines available, which costs a lot of money. It's a lot of engineering power. It's a lot of cognitive load to go through all these tools and figure out how they work and which ones you like and which ones you don't like and which ones work well with each other. So what the Kubefirst team has done is we've built a CLI that can install some of the best cloud native tools, some of the most popular, well-documented cloud native tools. Frankly, a lot of the tools that just about every Fortune 500 company ends up leaning on. Tools like HashiCorp Vault for secrets, tools like GitHub or GitLab for a Git provider, tools like Argo CD for GitOps. These are all Terraform for infrastructure as code. These are all very standard in modern organizations that have adopted cloud native. And we've just expedited the ability for you to have all these tools operational immediately. So you run a single command, and in a half hour in the AWS cloud, or even less time in the Civo cloud, and even less time on local, you can have all these tools working together just from a single command. So let's talk about GitOps. That's the point of today's live stream. We happen to use Argo CD as our GitOps engine. There are other GitOps engines that are available to you. Flux CD has a really good one. I understand that GitLab's getting into the space. And GitOps as a discipline. In fact, if you go to Open GitOps, there's a group that is dedicated to providing a vendor agnostic definition of what GitOps is. Highly recommend that you check it out before you pick your GitOps engine. We ended up going with Argo CD. The GitOps, generally speaking, is an engine that's responsible for delivery. You are no longer doing CI/CD if you're buying into GitOps. You're doing CI, and there's an engine that's responsible for CD, and that's no longer your responsibility. So in older paradigms, which have been coined now ClickOps or ScriptOps, in these older paradigms of application delivery, a lot of times you would find some script that was associated with an application pipeline that would do a kubectl command or a helm install command. And that's a scripted technology, that's a scripted implementation of getting applications into your cluster. And that's not what GitOps is. A lot of people think, well, I'm using Git and it's powering my DevOps pipelines. Isn't that GitOps? That is not GitOps. What GitOps is a new discipline where you define your desired state, and there's an engine that understands how to interpret that desired state and reconcile it with your infrastructure, reconcile it with your Kubernetes cluster. And if there's a delta, it'll apply changes to make sure that delta disappears and report back with the status. That's all GitOps is in a nutshell. It's a really nice way, massive benefits to application inventory, great security posture, great disaster recovery posture. We'll get into all that in our live demo here in a second. But GitOps is incredible, highly recommended for anybody that's embarking on a new Kubernetes adventure. Definitely start with GitOps. It's a much more sane way to manage the microservices that end up flourishing in your ecosystem. You'll start out with just a couple applications and it's easy to manage with a couple scripts, but before you know it, you have 100, you have 1,000 of these things, and asset management becomes a really complicated challenge that GitOps is able to reel back in. So with that, I think we're going to switch screens over to my buddy Jared. Jared's going to start out by showing us a little bit of GitOps and Argo CD on the Kubefirst platform.
Yeah, so let's see. Hello, everybody. First things first here. So we actually already provisioned a cloud installation of Kubefirst that's running on AWS and is using GitHub as its Git provider. This is 2 commands. You can follow our docs. You need a GitHub token, an AWS cloud, and a few other prerequisites. Those are on our doc site. But to save the 30 minutes that it takes to 35 minutes-ish, depending on your DNS propagation, to get to this end result, we went ahead and did this before. So I'm going to just drop straight into a couple of things. And in Argo CD, one of the most powerful things that we do is we leverage the bootstrapping capabilities, which is Argo CD jumping through sync waves and allowing you to kind of layer applications one on top of another as you go into adding stuff to your Kubernetes cluster. So just give me 1 second here to pull up the registry. And then if I drop back in the console, I can also open up the GitOps repository that we just provisioned in our new github org. Oops, one more time. All right, so the registry here has a whole bunch of applications, and the main thing that we are going to show here is that in this GitOps registry folder, we have a bunch of application kind YAMLs, and we'll take a quick look at one. We'll take a look at Atlantis. All this is doing is referencing another folder that's within this same GitOps repository. And if we go look inside this folder, which we do there, we can see that we have just some more YAML configuration. Atlantis happens to have a cluster role binding, uses a config map, some external secrets, and another application YAML. The application YAML being the actual installation of the Atlantis application. So a bunch of details in here I don't want to go too far into, but I wanted to show that each one of these YAML files inside the registry directory corresponds to an application in the Argo CD app of apps pattern.
Awesome. Yeah, and before we dig into running a sync and showing the Argo CD sync waves, if anybody that's watching this live stream wants to follow along at home, if you go to kubefirst.io, up in the top right corner there will be a Get Kubefirst logo. Yeah, right there, the button in the top right. And the example that we're showing here is the AWS with GitHub example. And if you just copy that code and change the green text values to values that are appropriate for your AWS environment, then you can follow along with all these same steps and sort of understand maybe a little more deeply all the nuances of the applications that come with the Kubefirst platform and how we've wired them all together in a GitOps oriented way. So Jared, can you maybe go back to Argo CD and kick off a sync of the registry and sort of talk through the sequencing of the Argo CD sync waves?
Yeah, so I'll click sync here, and it's going to happen kind of faster than I'll be able to keep up with. But when you see the last sync result here, Argo CD is kind of generating that. You can see that it's already starting to call out application-specific kinds that are listed here. And all it's doing is running through the set of sync waves. So if we want to look at that, what that actually looks like, if we look back in our components folder and look at external DNS, which I can't seem to see for some, external DNS is in registry, just kidding. Here it is. So we don't have any additional components to install with external DNS, so we don't wrap it in a components folder. But alas, here we are. So external DNS is one of the first applications, and you can see here that it's a part of SyncWave 1. Because it's SyncWave 1, it's one of the first sets of applications that Argo CD is going to add to the cluster and then reconcile the state until it gets to the desired state that we've set in Git. And if we wanted to look at Ingress Nginx, I believe it's going to be part of that same sync wave. So we have a few tools that have no dependencies that we can install up front. And then if we wanted to look at one of the later sync waves, like sync wave 40, we've gone through and we've added things like the Ingress, the external DNS cert manager. We've added HashiCorp Vault and made secrets management available. And then that'll allow all the other applications that we install through bootstrapping to be able to come up healthy.
So let me ask you this, Jared. With if you go to registry development as an example, that's one of the applications that was an app of apps pattern. And the app of apps pattern is a little bit different than that external DNS example that was just a Helm file and a single YAML file. It's instead a reference to a directory in GitOps. Those resources that are a part of development, those are sort of in their own SyncWave ecosystem. Is that right?
Yeah, so they get added to the end of the execution. We create the 3 environments in cluster. As your organization grows, you'll probably want to run those environments in other clusters. That'll be something that we're supporting coming soon with our cluster management feature.
That's awesome. Let's dig into the app of apps pattern and go through the process of adding a new application via GitOps. Like, let's show what that looks like.
Yeah. So let me grab my terminal over here really quick and drop into VS Code. So I've already cloned the feed kray GitOps repository here on my local host. And we were watching a Linkerd live stream last week, so we actually borrowed their sample application for this. We're going to go ahead and drop into components here and go into development. We're going to add a new instance of their emoji photo application to the development environment. So what that would look like is spelling matters. So I'm going to fix that. We're going to add a new file. This is just going to be the emoji photo YAML, which we can grab over here. Just 1 second.
For the emoji photo YAML, can you move that up into the development directory? You dropped in emoji photo.
Oh, thank you so much. Yep, I sure will. That's development. Wait, no, I'm sorry. That one's right. This is the this is the applications, the deployments, the services.
I'm sorry, I messed you up.
No worries. And that was a bad paste anyways. So we have the manifest content for the example application, the service accounts you can see, the services, and the deployments. And those are all going to be inside the development emoji photo folder. And then inside the development folder, we will add an emoji photo.yaml file that's going to actually represent the Argo CD application instance of that those resources. So if I were to save that here and drop into my terminal really quick, we can see the two things that we needed to add to get this, and I'm going to add. All right, and then I'm going to go open this pull request really quick, which I'll send over to John in Slack for discovery. And if we just do a quick review while he's getting an approval on that, just to just to recap here, we got the development application, and then we have the development folder with an emoji photo folder that's going to have all of the actual Kubernetes resources. And we go back to here. It's got the approval, so I'm going to merge this request and confirm. And now what this will do is this is going to mean that Argo CD is now paying attention to the main branch, or has been paying attention to the main branch, but now that that's in the main branch, we can either wait 3 minutes for Argo CD to naturally sync, or I can hit the refresh button here, and by refreshing, Argo CD checks into Git to see if there's any changes. It detected that there's this new emoji photo application, and that came up really fast before I could even get over here. So yeah, so that now we have the emoji photo application running in development. If I go into my, this is me connected to Kubernetes in my local terminal here, we can see all those applications are running in the development namespace. And yeah, so I guess we will go ahead and port forward to it really quick and open that up here. New application just added to the cluster. It's reachable over port forwarding to the Kubernetes cluster. And
all right, so a lot of times having a service isn't quite what an organization needs. They actually need it ingressed so that users outside of the cluster can access that application. Do you want to go through and add an ingress to these Kubernetes resources so that we can light up a access to this application from the outside world?
Yeah, let's do that really quick. So we've got the ingress YAML that we're going to now go ahead and add to that same registration point. It's going to be in that development subfolder and part of the emoji photo resources. We're going to set up the ingress to point to the service that we want to access. Because of the ingress Nginx cert manager and external DNS configurations that we have, just by adding this ingress and having this host spec and the TLS cert here, or TLS secret rather, it's going to go ahead and request a new certificate from Let's Encrypt that's going to give us TLS communication, and then store that in a secret and make our ingress accessible. So let me go ahead and cancel that port forward and add this. And again, I will have John approve this pull request that I open. Sent in Slack there.
approved.
Awesome. So we will go ahead and merge this pull request as well. And we're going to go back to Argo CD's UI, and we're going to go back to the development wrapper that we have here that represents the development environment. We're going to click that refresh button again just for expedience on the demo. And actually, I think I needed to click that in here. So I'm sure I surely did. So you can see here that now we've told Kubernetes to also add an ingress to this application. It's provisioning now, and as soon as it comes up status ready, we will hit that over the public DNS we just added.
There we go.
All right. So now we have this same application available serving traffic over the internet. We can check our certificate that we got from Let's Encrypt. And yeah, so these certificates automatically renew every 30 days. Just a nice piece of maintenance that we don't have to take care of using the platform.
Yep. Yeah. And, you know, don't want to turn this into a full Kubefirst promotion or anything, but all of these tools that are making all of that such a frictionless experience, external DNS, Cert Manager, Ingress Nginx, these are all tools that if you go to Kubefirst.io and run one of those AWS installs, that cluster that you get will not be an empty cluster. It'll be an exact replica of everything that you're looking at here, except instead of feedkray.com, it'll be your domain. So that is the one prerequisite that you have in AWS is you have to have a domain registered to a hosted zone. Aside from that, it can be a completely empty cluster. You run a single command and you get this entire ecosystem of all this stuff just working together the right way. So I'm hoping that saves a lot of companies a whole bunch of engineering time and R&D. So let's see, what do we want to look at now? We looked at the ingress. We showed how that works with the certificate and everything. Let's, do you maybe want to change the host name of Emoji Voto to some new host name so that we can sort of show a slower version of what that certificate issuing process looks like in real time?
Sure, let's do -2.
All right, so this is a host that we have never requested a cert for before. So this is more indicative of what you'll experience when you add your ingress the first time because you don't have a certificate that's been issued for that specific host that the cluster's never seen before. So when we apply this, let me give you another approval there, Jerry. Give me one sec.
Yeah.
And you are approved.
Awesome, thank you.
So when we apply this, there's a process that's going to automatically kick off where Cert Manager and Ingress Nginx and external DNS are all working together to solve a kind of complicated set of circumstances. You have a host that doesn't exist in the world at all, that needs to be registered in Route 53 or whatever your DNS management system is. And that needs to point to a load balancer. You have Ingress Nginx recognizing that there's a host that needs to be routed to a service inside the cluster. So it's going to automatically provision a load balancer and map the traffic that is associated with that particular host to that backend service. And then lastly, you have Cert Manager that's watching all of the ingresses in the cluster. And anytime there's a new host that it doesn't have a cert that matches, it's going to automatically go through and make a request out to the Let's Encrypt certificate issuer. That certificate issuer is going to say, hey, all right, so you're saying that your emoji voto development -2.feedkray.com. But I have to prove that that's who you are if I'm going to give you a certificate that verifies that you are who you say you are. There's a couple different ways that you can go through that verification process. You can either set up your Cert Manager to conduct a DNS-01 test, which basically means that it's going to create a record in your Route 53 that Let's Encrypt is able to check a particular value that's put in that record. And if the value matches, then they know you own that domain. So they'll issue cert manager the cert, and cert manager will make it available to your application. Or you can go with an HTTP01 check, which is basically the same thing, except instead of it being predicated on DNS records, it's actually going to produce a tiny mini little application and a tiny ingress with a well-known route. And cert manager is going to hit that HTTP01 route, confirm the value that you have in that small little HTTP01 verification. And if you pass the test, then they'll issue you a cert. Now, when it's a brand new cert like this one is, or rather a brand new host name, there's a DNS propagation that has to happen. So what we're looking at here on Jared's screen is a challenge that has been issued. And we have a new pod, this CM Acme HTTP solver. The solver has the answer to the HTTP01 check. And a request has been issued to Cert Manager to provide a certificate to the system. But the host name, the DNS, that Let's Encrypt needs in order to check that value needs to propagate through the internet. So there's this like 5-minute period where the DNS record has been established in the AWS hosted zone, and then that's being propagated to all the DNS servers, and then that'll eventually resolve with Let's Encrypt. It takes about like 5 minutes. On a really rough day, it takes 10. And then, but once Let's Encrypt is able to resolve that new host, it'll check the value from that HTTP solver. If the value matches, it provides the certificate to Cert Manager. Cert Manager provides it to the application Ingress, and Ingress Nginx will leverage that cert when it serves traffic to the end client. So a little bit wordy. That's the long and short of these three really powerful technologies. We call them the trifecta lovingly. They're like three of the first applications that we always install to a cluster. And they work really, really well together. Ingress Nginx, Cert Manager, and external DNS in dealing with the complexities of establishing new hosts, establishing new certs, establishing new host names, making sure there's a load balancer behind it, mapping the DNS record to that load balancer. It's kind of complicated stuff, but we've got it packaged in a way where it's really nice and frictionless. And all you have to do is add an Ingress Nginx to your cluster with a host name, and everything else will just take care of it for you. You can just kind of set your alarm clock to 5 minutes later, and you'll have an Ingress with a new host name with a cert, and traffic will route to it successfully and everything. So
power nap time, I think.
Yeah,
power nap, right?
That's right. At least we'll take a little break.
Yeah. We'll leave that up and check back in on it here in a few more minutes.
Right on. So what are we going to show next, Jared? Let's you want to dive into secrets and GitOps? Sure.
So a lot of times there seems to be a few ways that people add secrets to their GitOps ecosystems. There's what's the one by Bitnami called sealed secrets, is a really popular one. External secrets operator is the path that we've chosen. That gives you, and there goes our certificate. So real quick, I'll just hit this browser tab and refresh here.
You have to do a new tab, complete new tab in Chrome, like a new window, or else they'll cache that certificate.
All right. Yep. So here's the new valid certificate for the emojivoto-development-2, the KRayCom hosting. So
very cool. Thanks, bud.
Yeah. End of that. All right. So we're going to go to secrets. So let's go to our HashiCorp Vault instance. -vkray.1.
No, .com.
No. Oh, thank you. Sorry. Too many domains around here. Let's do.
Pay no attention to the man behind the curtain.
Let me grab the password for our SSO user here. Our SSO user comes by default as KBot, so that you have some way to access the system. We've signed into Vault using that SSO, and we go to secrets, development, and we're going to add a new secret for the Emojivoto application. So we're going to do, oh, that's in the wrong spot. We want that to be in the path. And then we're going to do an example. And we're going to call this value super secret. Make sure I spelled that correctly, and I did. So for our applications to get at secrets, first, we always add them to HashiCorp Vault. That's the source of truth for all the secrets across the entire platform, always. And so now the secret lives in Vault, and Vault knows about it. So the next thing that we need to do is to be able to get that secret out of Vault and into our Kubernetes ecosystem. So we're going to go back to our GitOps repository and revisit the Emoji Voto application and the resources that we have here. If we go ahead and do external secret YAML, we can grab this off screen as a cheat, because I'm not going to bore you with writing YAML on the fly. I will mess it up and it will take longer. So let's copy and paste that here. So this is a new CRD that comes from the external secrets operator. We generally have them as sync weight 0, but that doesn't actually matter here. So I'll remove that for clarity. This is going to take and create an external secret object called Emoji Voto Secrets. It's going to place whatever the outcome of the secret is in a secret, a native Kubernetes secret called Emoji Voto Secrets. This secret store ref just has a little bit to do with how the external secrets operator pulls Vault to get the values of those secrets. You would be able to find that in this external secret store resource here if you wanted to dig in a little bit deeper and you've done a Kubefirst installation, you're looking in your GitOps repo and you want to know where to go. That would be there. You could just search for this name value in the GitOps repo and you'd be brought right to it. The only other thing is we are going to look at the development / Emoji Voto path, and we want to get the property example, and then it's going to place that in a Kubernetes secret, as mentioned, with the name of Emoji Voto Secrets and with a data key of example. So I'm going to go ahead and put this pull request forward as well to add a new secret. All right, and this is going to be opened up to send over to John. Pull request 4.
And you are approved.
Awesome. So now that it's approved, we can add this to our Kubernetes cluster as well. With that merged, all right. So we're going to drop back into the Argo CD UI, and we're going to again refresh the Emoji Voto development. Argo CD is going to recognize that new resource in Git, and it already provisioned here. And then it created the Kubernetes native secret with the same name of Emoji Voto Secrets. So if we want to go ahead and take a look at that value, ooh, it's not there. Or it is there, that just wasn't autocomplete. Misspoke on that. So secret, perfect, that's what I was looking for there. If I go ahead and look at the value of the data and then the example key, as mentioned from the external secrets YAML, it's placed the value super secret here in that Kubernetes secret. And then just to kind of show the way the external secrets is wired up, if we go back to the YAML resource, we can see this refresh interval of 10 seconds. That can be set to whatever you like, but for demos like this, it's a really great way for us to be able to update a value. So I'll expose all of our super secrets and make this a new value. And by doing this, if we wait just 10 seconds, so I guess starting now, or we see this resource pulse, which is that pull from external secrets operator, checking in on the resource. Hopefully we should be coming up here in just a couple more seconds. There goes that pulse. So if we drop back into our terminal and we just get that secret value again, it's already been updated and hydrated with that new secret value. So allowing your applications to take in secrets and update those values becomes very easy and easy to do and also easy to manage. So if your engineers are making changes, HashiCorp Vault also gives you a nice versioning scheme. So we could also go back and take a look at the different versions. We can roll back to the previous version, and then still external secrets operator would automatically update that value in Kubernetes for your application.
Awesome. Yeah, and just to highlight a couple details about our Vault story on the Kubefirst platform. In the AWS ecosystem that we're demonstrating here, HashiCorp Vault's data store is housed in DynamoDB. And the Dynamo instance that we're leveraging, or the Dynamo space that we're leveraging, I guess, has point-in-time recovery enabled by default. And all of the secrets at rest are encrypted with a KMS key that we create for you and wrap all your secrets in during the provisioning process. So from a disaster recovery standpoint, obviously, if you're putting all of your secrets in a single source, that source is very, very valuable to your organization. But we have a really good story around adding redundant layers of backup and of recovery capability at 3 different layers, and it's all encrypted at rest. So really good vault story in terms of not just keeping your secrets out of your Git repositories, but also having that really hardened disaster recovery setup with a point-in-time recovery and the encryption at rest and everything. It takes a bit of time to get that all implemented correctly, and you get it in the first second with Kubefirst. So worth calling out, I suppose. So let's see, Jared, where should we be going from here? We have
I think we were going to look at a metaphor front end change.
Oh yeah, let's do that. So the state of metaphor, would you mind bringing up metaphor front end development dot
that's the wrong domain again. Look at me go. Just another domain we have laying out there. So here's the development instance.
Right. So the story here is that we had a change recently where we got rid of a purple banner that was across the top of the Kubefirst front end application, and we want it back. So what we're going to do here is sort of simulate what rollback looks like when you're doing application delivery in a GitOps ecosystem. So I was describing a little bit before when describing how GitOps works, that you're no longer responsible for continuous delivery. You're only responsible for setting that desired state. Now, that desired state is a Git repository, and it's in this case, it's a GitOps repository that we create for you, that we put in your GitHub, so that you get to keep your infrastructure and the desired state that's powering that infrastructure. Jared, if you could go to the development chart and look at the history of that chart, this will show all of the changes that have ever been made to the development environment. We went from an O.0.1 to an O.1.1 to an O.2.1, et cetera, et cetera. And whenever we make a change, if you would look, Jared, at the that topmost commit, this will show that the most recent change of delivering a new version of the application to the development environment, all you have to do is set the new version that you want in development. And Argo CD will take care of making sure that it delivers to development. If you would go ahead, Jared, and just copy that top line and then make a change to the GitOps repository so that that's the new value. This is going to emulate the rollback of an application. Basically, there is no longer a rollback. You don't need to go back to your CI ecosystem necessarily. You just have to go to your GitOps repository and make sure that your desired state is the desired state that you want. And in order to know what desired state you want when you're in a rollback circumstance, you just have to look at the history, see what the most recent change was, and change it back to the version before that change. So there you just saw Jared making a change. Did you change that directly in the main branch? It's ready to refresh?
I did, yeah.
Sweet. Yeah, so we'll refresh this app here, and then here as well. And this should pick up the fact that we have a new desired state for what version of Metaphor we want delivered. You can see it's got a new pod that's spinning up. It's running, it's waiting for it to show healthy. And as soon as it's showing healthy, it'll start destroying the pod that was there a moment ago. And right now at this point, Jared, if you hit a refresh, now we have the purple banner back. So that's all that it takes to iterate, to roll back. And from a CI standpoint, from an application continuous integration standpoint, the job simplifies quite a bit when all you're doing is dealing with desired state and you no longer have that concern of continuous delivery. Really, your job is to publish a container, get that container published into a Helm chart if you choose to deliver with Helm, and then set the desired state for your application instance to have that specific version. So Jared, do you want to maybe show a little bit about like the different desired states for development, staging, production, kickoff a build, and maybe just sort of show that part of the ecosystem? Because the other way that you could do it is you could go back to the application and revert the change on the application side, which would then build a new container and it deliver that desired state to Kubernetes, which is just as effective a way to roll back an application. But in none of these circumstances are we going back to some old CI execution and rerunning it, which is how a lot of script ops oriented delivery patterns work. It'll be like some Jenkins job, some Argo workflows job, whatever your CI system might be, would have the ability to build and then kubectl apply some content to Kubernetes. And a lot of times the paradigm to roll that back is to go back to some old pipeline and just run it again. But with GitOps, it's all different because it's all predicated on the main branch of your GitOps repository. So you can just manually change these desired states, or you can rerun your, you can make a proactive change to your application's Git repository so that it starts a new published job and starts delivering that to your development and staging and production environment.
Great
so
explanation.
while I was rambling there, Jared, what do you have kicking off?
I just went ahead and made a white space change to the main branch in the README in the Metaphor front-end repository. That went ahead and triggered a GitHub action. The GitHub action is just a nice shim layer that we have that's actually invoking Argo workflows. So if you were to drop into your GitHub actions, this publish job will output the same container output that you're getting in all of these steps here, but just hopped into the Argo workflows UI just out of convenience, really. And now we just have to wait another 2 minutes and about 30 seconds for this image to be built and published. So I don't know where to go and where to kill those couple minutes, but CI is kind of boring to watch.
Yeah, I guess we could talk a little bit while we're waiting on the publish to complete. We have a handful of different Kubefirst environments that all behave in very similar ways. So we have a GitLab ecosystem for AWS, and in that GitLab ecosystem, we have a GitLab runner that's running in your Kubernetes cluster that's invoking an Argo workflow, or the GitHub flavors of Kubefirst that we have. We have Kubefirst local, which is a really nice lightweight way to check all this stuff out. If you don't want to deal with like creating a new cloud account and adding a credit card and doing all of these prerequisite steps, then you can just run Kubefirst local, and you can have basically the equivalent environment just running on your local host, all for free. So that's really nice. That's also a GitHub ecosystem. This version is the AWS GitHub version. And we also have a SIBO release that's coming out, we think, next week, where you're going to be able to run the Kubefirst platform in a SIBO cloud instead of the AWS cloud. SIBO cloud's kind of neat. It's a lot less resources to manage from a cloud standpoint. So if Kubernetes is front and center and you're buying into putting the lion's share of your infrastructure in a Kubernetes cloud native ecosystem, the Cibo Cloud is a really nice place to start. In order to have the equivalent of an EKS cluster, which is like really, 40, 50 cloud resources that need to be terraformed. On the Cibo side of the house, it's only 3. So it's like a lot less Terraform, a lot less moving parts for basically the equivalent cloud native powerful ecosystem that we're delivering. So
before you get started too, I have other things. Michael, who is watching over on Twitter, who works on Argo, wrote a comment that said script ops is a good word, and he's going to be stealing it. So
that's awesome.
Know that you two are influencers.
well, before we get that far.
I don't know if I could take another ops, but
if you steal from me, you're stealing twice. That is that's a term that we stumbled upon and also loved. It's ClickOps, script ops, and GitOps are basically the 3 ways to change Kubernetes clusters. You can be in your terminal and running a kubectl apply. That's your ClickOps ecosystem. You could even be in Argo CD and be doing ClickOps. You could be in Argo CD's user interface and clicking that you would like a Helm chart and typing in the parameter overrides that you would like. We happen to be very strong advocates for the GitOps discipline. So we tend to say never ClickOps at all. Unless you're doing rapid prototype development in an ephemeral environment. A lot of times it is really nice and convenient to hop into an Argo CD user interface and just kind of mess around with the parameters until you get it working the way that you want. Then you can just hop over to the manifest YAML, grab that YAML, drop it in your Git repository, and then boom, you've GitOpsed it. So, and from a script ops standpoint, it's a shame that that term didn't exist when its popularity existed. But it is a nice way to be able to describe that. Agreed.
So it looks like that was enough minutes to kill to get us to be able to release that new change to the main branch to development and staging. So if we go back to our GitOps repository, we can see here that we're updating that revision to be the new RC 15279 all over the place. And then in production, it'll be 031. But if we go to development and the Metaphor front-end application, you can see it's just 1 minute ago, that was the version that we changed. And now when we go out here to the new ecosystem in the new browser tab, like John just told me, oh no, it's still the same. Well, that was not as exhilarating as we were hoping for.
Sorry, that was after did you see refresh?
I'm sorry. Oh no, I did not.
There you go.
Good catch. Yes, that was the 3 minute poll that we missed there before I came back into Click. So we'll just wait another 30 seconds for this to come up or so, and then refresh that tab. I'll get that URL.
That is an important distinction to highlight about GitOps. A lot of shops that are used to script ops and used to there being a command in their CI/CD pipeline that says kubectl apply or Helm install. There's an instant gratification that happens, right? Your kubectl apply, as long as it was a successfully executed command, that means that Kubernetes resource will be in Kubernetes immediately. In GitOps, generally speaking, the discipline shifts a little bit so that you're setting your desired state in your Git repository. And then you just have downstream CD engines that are pulling your desired state and reconciling that desired state against the cluster that the GitOps engine is managing. So there's oftentimes going to be a little bit of an extra lag after you set that desired state before it becomes reality. And that kind of opens up an entire can of worms, because then you can get into rollouts and you can script the syncing operation, and you can do all kinds of different things. All your options are available to you, but by default in a just default installed Argo CD GitOps ecosystem, you're going to set your desired state, and then It depends on how lucky you get. It might be 1 second. It might be as many as about 3 minutes while Argo CD is conducting a poll. But within that 3-minute period, without doing something proactive, that poll would happen and it would begin to reconcile that against your Kubernetes cluster.
Sweet. Awesome.
So let's see, we covered rollbacks, we covered application delivery, we covered secrets in a GitOps ecosystem and keeping your secrets out of your Git repositories. We covered adding an application in a GitOps environment. We talked a little bit about Kubefirst and how easy it is to have an environment that works exactly like this one. You can see from the timestamps of Jared's GitOps repositories, this entire cloud didn't exist until 4 hours ago. We just ran a command, and now we have a complete cloud ecosystem powered with Argo CD and Vault and Argo workflows and all kinds of good stuff. So check us out. Go to kubefirst.io and give it a whirl. And we're at a stage right now where we're very actively seeking feedback. So if you guys have thoughts, if you have friction points, we're truly trying to create the best, most frictionless Kubernetes ecosystem for day one of any project. So anything that you think might embolden that story, we would love to hear what tools you think the platform's missing. The platform itself is extremely extensible. The way that it works, we have an upstream GitOps template repository. When you run an install, we pull that down from our upstream. We hydrate it with the opinions, the parameter input that you provided us about where you want it installed, what region you want to install to, what your domain name is, details like that. That Git repository that we hydrate, we then give right back to you. So you can host it in your own GitHub, you can host it in your own GitLab. And you saw just a moment ago that changing what's delivered is just a matter of a simple pull request. So you'll just be pull requesting against your brand new mint condition GitOps repository and be able to create these management clusters rather frictionlessly. And in upcoming months, we're going to be tackling cluster management so that it's not just a management cluster. It's got your, you can have your development and staging and production clusters, traffic switching, details like that. So keep an eye on us. Stay tuned to our story. Please give us any feedback if you do try out Kubefirst. Find any points of friction. We have a Slack community that boasts a helping hands channel where it doesn't matter what your question is or how new to Kubernetes you are, how new to Vault you are, how new to Argo CD you are. It does not matter. Hop in the Kubefirst Slack and you can even just lurk in the helping hands and see firsthand that we will answer just about any question. So I hope you join our community. I hope we can help you along on your cloud native adventure. Yeah. Thanks for joining us today.
Awesome.
Yeah.
Great job, guys. It was very informational, super packed with.
Yeah, it's a lot.
I'll have to replay, even if I was live watching. I need to replay and remember half the things you said too. But
right.
It's been great. Awesome. Stay tuned for the next one. We'll be doing a couple more of these in the future. I don't know if I'll be hosting. We'll have Fred, who is a developer advocate for Kubefirst, will be host. I'll probably pop in just to say hi, because I love doing these anyway. But stay tuned over the next couple of weeks. Awesome.
All right.
Thank you, Kelly.
Thanks, everyone.
See ya.
Thanks, Kelly.
See you guys.